In this question, they're asking us to solve a differential equation, dy by dx minus x equals 3, and that y at 1 equals 0. So what does this mean? Well, this is a differential equation because, first of all, it's an equation. There's an equal sign. And second of all, it's a differential equation because there's a derivative in it. So they would like us to find some function y. We don't know what it is yet. They would like some function y so that when we put it into this equation, it makes the left-hand side equal to the right-hand side. But they would also like that function, y of x, to be a function such that when you plug 1 in for x, what you end up with out of the result is 0. So let's try to make the first thing true. So the first thing is we need to satisfy this. So the way to actually do that for these simple cases is to keep only the derivative on the right-hand side and move everything over to the left-hand side and move everything over to the right-hand side. So we have dy by dx equals 3 plus x. And the way to undo a derivative is to take the antiderivative. So if we want y, not the derivative of y, what we're going to do is take the antiderivative of both sides. So we take the antiderivative of the left-hand side, and of course the antiderivative of the right-hand side is the same thing as the indefinite integral of the right-hand side. So there we go. And now we can use our indefinite integration rules to actually separate these into two separate indefinite integrals, x dx. And then we can use our formulas to tell us what these antiderivatives are. This is 3x plus some constant c1 plus 1/2 x to the power of 2 plus some constant c2. And this is some arbitrary constant. I don't know what it is. It's c1. I don't know what c2 is. Just some other arbitrary number. So, of course, an arbitrary number plus an arbitrary number is just an arbitrary number. So what I can do is actually simplify this into 1/2 x to the power of 2 plus 3x plus these two arbitrary constants are just added together to make another arbitrary constant plus c. What you'll find is that this function, y is equal to this, so y of x, so this function, if we use this, if we take its derivative, plug it back into here, what we'll find is that that actually does make the left-hand side equal to the right-hand side of this equation. However, the question also wants us to make sure that when we plug 1 in for x, the y that we get, the result that we get is that it equals 0. So let's just make sure that our function y does that. So at x equals 1, okay, so let's plug that into our function. Y at 1 is equal to 1/2 1 squared plus 3 times 1 plus c. And if we simplify that, what we get is 1 squared is just 1, so this is 1/2 plus 3 plus c, and that equals 7/2 plus c. Now, that's what we get when we plug 1 in for our function. But what do they want as the result when we do that? They want that to equal 0. So we want 7/2 plus c. We want this to equal 0. So let's figure out what c has to be. So c, if we move the 7/2 over, has to be negative 7/2. So indeed, now we have the final version of our function, y of x equals 1/2 x squared plus 3x, which comes from our work up here. But now we actually know the value of the constant. The constant has to be negative 7/2. So now we have a function that, when you take its derivative and put it back into the differential equation, it makes the left-hand side equal to the right-hand side. But we also have a function that when we sub in x equals 1 into here, what we end up with is 0, which is exactly what they would like out of our function. So this is the solution to that differential equation.